This is Patrick Dolence with another PowerPoint for ISECON 104, Introduction to Macroeconomics. In this PowerPoint presentation, we will build our first model relying upon the concept of opportunity cost. Opportunity cost, as you may recall, refers to a situation where scarcity requires choosing and the choice involves sacrificing alternatives. More specifically, we refer to opportunity cost as your next best option, or the choice that you forego when you make a decision. To model opportunity cost, we're going to simplify things. We're going to assume only two regions. In this example, the state of Washington and the state of Oregon. And we're going to assume that in each of these two regions, only two productive activities take place: catching salmon and bottling wine. We simplify the story to two regions so that we can focus on the relationship of the opportunity costs between these two respective neighbors. We simplify with only two productive activities to make it very clear that the next best option when either productive activity is pursued is the alternative activity. In order to work with opportunity cost in this example, our model first requires that we determine the maximum level of output, both for salmon and for wine, in each state. Then we're going to use that information to construct what are known as production possibilities graphs. First, we'll focus on the maximum levels of output. The following table will be used for taking specific productivity information for each region and translating it into the maximum level of wine or the maximum level of salmon that can be produced in Washington and in Oregon. We will start our story with the state of Washington. In Washington, we assume that it takes 1 hour to produce a bottle of wine, but only 15 minutes to catch a 1-pound salmon. We assume that Washington has 100 hours of productive time available. The first question that we're going to answer is, what is the maximum wine production? In other words, if Washington devoted all 100 hours of their resource to winemaking, how many bottles could they produce? The next question that we'll answer is, what is the maximum salmon catch in Washington? And for that question, we'll assume that the entire 100 hours of productive time are devoted to fishing. So first, the wine production question. If it takes an hour to produce a bottle of wine, and we have 100 hours available, then it's a very simple quantitative problem to determine that using all the time exclusively in wine production would produce a maximum of 100 bottles of wine. 100 bottles of wine in Washington is possible only if no time whatsoever is devoted to catching salmon. The second question that we were supposed to answer, is, what is the maximum salmon catch? If we took the 100 hours and devoted it entirely to fishing, foregoing wine production completely, we could catch one fish every 15 minutes. And therefore we could catch 4 fish per hour, and we have 100 hours to work with. So therefore, if all we did was fish, Washington could produce 400 fish, or 400 pounds of fish, since we assume that each fish weighs 1 pound. Notice in the table that we can produce a maximum of 100 bottles or a maximum of 400 pounds of fish. But obviously, if we want some of each, we'll have to give up those extremes. Our next task is to complete the table for the state of Oregon. To do that, we're going to need productivity information for the state of Oregon. So let's see what we have. In Oregon, we assume that it takes 30 minutes to produce a bottle of wine. We also assume that in Oregon, it takes 20 minutes to catch a 1-pound salmon. Notice that each of these productivity times look different in the state of Washington. That will be important in the next presentation. We're also, for the purpose of this example, going to assume that the state of Oregon has 100 hours of resource to work with. And we're going to ask the same two questions. First, what is the maximum amount of wine that could be produced in the state of Oregon? And then second, what is the maximum salmon catch if all Oregon did was exclusively fish? So again, the math involved here is something you can do in your head. If we have 100 hours of time and all we focus on is wine production, it takes 30 minutes to produce one bottle, so in an hour we can produce 2 bottles of wine. 2 bottles per hour, 100 hours to work with, generates a total maximum production of wine with no fish whatsoever of 200 bottles. To answer the last question, the maximum salmon catch, we apply the same logic. It takes 20 minutes to catch 1 fish. So in an hour, we could catch 3 fish if all we did was engage in salmon production. 3 fish per hour with 100 hours to work with yields a maximum salmon output of 300 pounds. Notice once again the word "or" figures prominently for the state of Oregon. That's because the maximum output of 200 bottles of wine assumes absolutely no salmon whatsoever, and the maximum salmon catch of 300 pounds assumes 0 production of wine. We've now completed the first task. Our next task is to construct what's known as a production possibility graph. The production possibilities graph is used to capture the opportunity cost of the 2 different activities. And indeed, we now have a second reason for simplifying our example to only 2 productive activities. The first reason, as you'll recall, is it makes opportunity cost very obvious if there's only one alternative. But now, as you'll see, when we want to construct a 2-dimensional graph, that is to say a graph that has a vertical and a horizontal axis, and because we want to put productive activities on the axes, we need to limit our focus to just 2 activities. So first, we'll do the state of Washington. In the state of Washington, if all they do is bottle wine, we know that 100 bottles is the maximum, and we know that corresponds to 0 pounds of fish. So one extreme on the graph is 100 bottles and no fish. The other extreme, based on our table, is 400 pounds of fish but 0 bottles of wine. When we graph these 2 extremes, or intercepts, and then connect all the points in between, we get the production possibilities graph for the state of Washington. Notice that there are many possibilities in between the 2 extremes. For instance, if Washington spent half of its productive time in wine production, they'd get 50 bottles, and the other half of their time would produce 200 pounds of salmon. So one point on the production possibilities graph is 50 bottles of wine and 200 pounds of salmon. In a similar fashion, we can construct the graph for Oregon. 200 bottles of wine would be one intercept on the vertical axis, corresponding to no salmon whatsoever, and 300 pounds of fish would be the intercept on the horizontal axis, which corresponds to 0 bottles of wine. 3 more quick points before we conclude this presentation. First of all, any point along the production possibilities line represents an efficient use of resources with no waste. That is to say that any point that sits on the line, either for Washington or for Oregon, represents the complete use of resources in wine production and salmon catching. The second point to be made is that any point that's inside the line, that is to say a point that is between the origin of 0, 0 and the line that we generated for either Washington or Oregon, is an inefficient use of resources. By inefficient, we mean that it's possible, but we could do better because we're not using all of our resources. It assumes that some resources were unused or wasted, and we had no productive output to show for it. The third and final point that we want to make about this production possibilities concept is that all of the points that sit beyond the line, that is to say 200 bottles of wine in Washington and 500 pounds of salmon, for instance, are not attainable with existing technology under existing circumstances. So points beyond the production possibilities line represent options that are not available without either additional resources or technological innovation or some other economic magic, the details of which we'll talk about in the next presentation.